Okay, hey guys. So yeah, we are Dokai, and we'll be presenting today. And the theme that we had in mind was Houdini for games, because most of the events here are all focused on special effects and stuff, and we wanted to go a little bit more into games. So, quick disclaimer: we don't know everything, or actually that much, but we try. And all the stuff that you're going to see is either still partially in development or it's our take on stuff. You know, so in Houdini there's a lot of different ways of approaching problems, and there's a lot of the solutions as well. So what you're going to be seeing is like our solutions to these specific problems and our approach to these problems. So in this presentation, this is what we're doing tonight. I'll be quickly introducing us. Then I'll be showing some pipes. It's just a tool for in Houdini and then used in Unreal to show like the workflow. Then I'm going to hand it off to Feike, and we're going to talk a little bit about what an intersection is. Then the problems on the road, so to speak. And after that, we'll have some time for Q&A. So we are both students. We're undergrad students right now. We're in our fourth year, so senior students at a university that was previously called NHTV IGET, International Game Architecture and Design. It's a very long name, so they just call it BUAS right now, or Breda University. It's located in the Netherlands. And in our free time, we started Dokai. So what is Dokai? It's this guy, Feike. Yeah. Slicky stiff. I mean, I'm not that fancy usually, but yeah. So there's like a few tutorials that we already brought out. These are some of them that you can find on the website. And the bottom one, the Complex Road series, that's what got a lot of attention on social media. Different websites like 80 Level and other stuff. They got into it and they shared it a lot. And we got a lot of questions as well on YouTube and on Vimeo. A lot of people are interested in it. So that's the main topic of tonight, the intersections. Then this is our website. The video that we're recording right now will also be published there. So if you want to look back at it, if you want to take a look at what we're doing, then you can also see that at our website. So I'm just going to be showing off some stuff. The first part I'll do in the PowerPoint presentation, and the second part I'll quickly jump into Houdini and then into Unreal. So the first thing that our university was always pushing onto us is like reference is important, right? So you need to know what kind of stuff you're building and why you're building it, and how would you know? It's actually true. So I went around the parking lot here and I took a lot of pictures of the pipes because I was going to make a pipe generator, and we have like all different types of pipes going on. So on the top left you have like a bike rack that's right around the corner. And then on the bottom, you have like different types of flanges, you have different corner pieces, all kinds of different stuff, and they all connect together. And I wanted to make one tool that basically can do all of that for a designer. So that's the second thing. It's not just about reference, but it's also what do you want, or more accurately, what does your end user want, right? So the designer in the game, how are they going to use your tools? So I looked at a few things. This is the first like version in Unreal Engine, and it's just spline based geometry that gets generated. So it's very easy for a designer to quickly work around with this. So how I build it is just like on this picture you can see it. I put a grid on it, and then I looked, okay, so pipes are usually just pipes between two points, and these points are the ones that get connected. So that's something that I wanted to have access to for the end user, just simple point controls. Then the second thing was the different radii, or the diameter from all the different pipes. As you can see, all different pipes connecting, and they all have different sizes. And then there's like all these different parts. You have different corner pieces, you have flanges, you have bolts. In some cases you have some add-ons like valves. And then where the pipes connect to the real world, you have like the connecting pieces. And then of course all the different materials. So one of the things that I wanted to give control to be able to use all these different things is the offset from each point until the part where it no longer curves. Right? So as you can see on the left image, it's a very short distance from the green point until the red line. Well, on the right image, you have a lot bigger distance. Well, they're basically made out of the same material. So these are controls that or at least I wanted to give to the end user. And that leaves me with the basic interface that I created. So on the left side, you see the interface in Houdini, just a quick work mode with different options. So you can set the diameter, you can set like the divisions, and you can actually scale the UVs as well. If you have like a smaller object, you probably want less UV speeds for it. So it's a little bit more optimized. And on the right side, we have that same interface generated through the Houdini engine in Unreal. So there's no like weird stuff going on. So in Unreal, this is how it looks. We have like a basics line, and then on that gets the geometry gets generated, which is showing the UVs. You can still see all the corner points. So this is very easy to use, and any designer could just grab a point and switch. And then this is a little bit more advanced parameter interface that I created, where you can actually specify if you want hard or soft edges, or I made some material presets that you can use. There's like different add-ons and stuff that all work together to create the final asset. And then again, on the right side, you see how that results in Unreal. So again, we have our basic stuff, and then when you turn everything on, you get a nice looking asset. And the cool thing is that it's procedural, so you can still change up all the different things. And that's actually the power of Houdini. Because if you're usually working in a basic game environment, you'll probably have like a designer drawing this out, and then a modeler creating this, then a texture artist going over it, creating the textures and whatnot, and then you're putting it in game, and then the gameplay gets tested, and they're like, oh, well, this doesn't look good like this, it should change. And then you have to start the whole thing again. Well, here, when playtester is like, oh, this doesn't work, then designer can just drag around one of the points, and it updates, and it's done. So it saves you a lot of time. So I'm just quickly going to go over the nodes that I have in Unreal, in Houdini, and then I'll switch to Unreal. So right now, this is the work mode that we had. You can see on the right bottom hand, that's the Houdini nodes. So every node does a specific thing. So this is the node that I created that generates the pipes, and then here you have the parameter interface. And then here you have your viewport, where you can basically see what you're working on. So I have different input curves. So an example, I have this curve, and then it automatically updates, and it gets to this final state. Or I could put in an even larger curve that has even more stuff going on. So if I look inside of here, just quickly going over it, we have our basic curve. And then I'm just going to click it so you can actually see what that is. So we have our basic curve. And I just poly bevel. Oh, just give me a second. And then here we have our poly bevel, which basically rounds off the edges. And all those things correspond to the things that you see. So these corner divisions, actually, if I set it to 2, it actually works here and sets it to 2 as well. And then based on this specific line that we generate, we actually generate a geometry as well. So we sweep that around based on our original cross section, which is a circle. So this circle gets placed around. And that's basically the start setup of how this pipe generator works. And if I go here and I would switch it from work mode on to this more advanced mode, I can actually add geometry. And as you see, a lot of different stuff gets added. So we have the end parts, we have different add-ons like valves, we have corner pieces. So all of that works together. And then based on these settings that I have here, I can all change it up. So maybe I don't want valves every, I don't know, like straight piece that I have. So I can just make this bigger. And now out of the points I have, 1 out of the 2 segments gets 1, but there's 3, so it starts again. So it's 1 out of 2. And then again, if I'll add that to 3, we should have only 1. And then with the offset, I can just basically say, okay, but I want it actually at the second one or the third one. I just keep iterating on the stuff that I'm doing. So I'm just gonna turn this one on, and then you can see it still grabs every piece, and then it sets it off by 2, and it grabs every 1 out of the 3 points. I can actually up this. As you can see, there's too many points here right now, so it's only creating 1. And then with the offset, I can switch it around wherever it's coming from. Okay, so then the second thing that I did is I wanted to make sure that if I don't want these bigger corner pieces, that it actually creates stuff like flanges. So if I go to my corners and I would turn these ones off, you can see they automatically change to flanges. And it's not just a simple on and off switch, actually. I could also change this one up, and then where there's no corner piece, it will automatically generate this. And again, also this I can easily switch by offsetting it. And how that works, I'm quickly gonna go into my flanges, is the flanges have geometry and they all get created on specific points. So if I go here, these are the points where the corners originally are, and I group the points that are within them, and then I basically delete those points, and that's where I'll have my finalized points. So then if I copy the geometry that I created previously, which is this specific flange, if I copy those to the points that are existing, and I will copy it onto there. And they all use different expressions to get the actual like amount of points, because in some cases you need 1 point, in some cases you need multiple points. And that generates my final output here. So that's how this is all generated. And then again, if I just have this curve and I were to grab, say, a point, let's see, and move this around, you see that everything still updates. Everything works pretty fast. It generates everything on the fly, which makes iterating really fast and convenient, especially for designers. So I'm going to switch to Unreal right now. All right. So in here, the digital asset gets created, or at least I imported the digital asset. So if you have Houdini engine installed in your Unreal or in your Unity, you can actually access those assets that you made in Houdini, and you can use them in Unreal. So if I just drag this one into the scene, it will ask me which version of your tool, because I iterated on different versions. And obviously for this, I want to use my latest one. And you can see it automatically gets generated, and it's just the basic thing that we had before. So now if I'm playtesting and I'm walking, I can actually walk through it, which means that if I'm in a level where there's somebody playtesting, but I also want to iterate on the looks without interfering with the playtesting, I can just use this. But as we said, we also have something that's not a work mode. So if I toggle that and I hit play, now if I walk, it actually creates collisions. Right? So it's very fast and easy to iterate. So if the designer is like, okay, this is how I want it, just switch it off from work mode to your actual mode, and then people can actually play test it. So again, here as well, we have those small points. You can see them, and just by clicking, I'm just going to turn my work mode on again, and just by clicking and dragging, you can see that it generates pretty fast. I can actually move some stuff around. Make some crazy shape. Let's see. Go up. As you can see, this is actually pretty fast compared to, oh, I want this line to be a little bit different. Let me have like a modeler create this, and then an artist like go over it, give it like whatever sections, and so it's a lot easier for any designer to actually work with this. All right, and then when I'm like, okay, well, this looks good, let's switch from work mode. Then we have our different material presets and our different edges. Well, let's set this to soft edges so it looks a little bit more like a decent formed pipe. Let's increase the corner segments a little bit. So we have nice round edges going on here. And then let's actually add some geo. As we saw before, all the valves get generated on every single point right now, but we actually don't want that many. So on the valves, I can actually say 1 out of 10. I just change that, and there we go. We have 1 out of every 10. And again, it's all generated, all has collisions. So this iteration work is very fast to do. So in my pipe generator, I created some materials that you can see, and those can be pre-generated. If you right mouse click on them and you go to your copy reference, you could actually go into your Unreal scene, or in your Houdini scene, and if I go to where I create my Unreal materials, you can actually see that I have that specific reference path that I created. So I create something in Unreal, like a material, and I reference that here. So whenever it gets instanced in Unreal, it automatically finds that specific path. And the convenient thing about that is that if I'm here and I want to have a different material, say I want to have brushed nickel for some reason, then it just auto updates. Maybe burnished steel. Maybe I want to have like a older looking one. I just add rust. Okay, so then if we walk to it, you can see like it looks like an old rusty pipe. And maybe the quality is not high enough, so we can actually change with the UV settings, and because of the UV space, it will automatically update that. So one of the things that I wanted to create, of course, was the was the bike rack that we saw outside. Right, so that's basically nothing more. I'm just quickly going to generate that one as a curve that just goes up and down. And it has the same, has the same space. Let me just get out the point. Has the same space in between all of the different points. Alright, let's zoom in with it. Alright, so in here, I want to switch from my work mode. And I know that it's not going to be this thick, right? So I'm probably going to make this like, I don't know, say 5 centimeters in diameter. And then the corner parts, maybe I want to have them a little bit higher quality. And then I want to have soft edges. And then instead of steel, I want to brush nickel. And maybe I want to offset this a little bit more, so we get a nice round feel. And there we have our bike rack that's right outside the doors here as well. So that's how easy it is to just iterate on different tools or different things that you want to create. Yeah, so that basically concludes it for this workflow from Houdini to Unreal for me. So I'm just gonna close this one down. And from there on, I'm just going to give the word to Feike.
All right, yeah. So my name is Feike, and I've been doing a lot of focus on the complex road series. Like the first time I got into Houdini, I was also busy with roads. The first thing I made was actually a sort of scaffolding system, like a minecart rail for a short animation. Was that really great? But still, like the roads really got to me, and I've been keep on iterating on them, keep on making different road systems. So this is what we currently have. This is a little bit about how it works. So it uses a wireframe as input, or OSM data. Who here knows OSM data? Can you put your hand up? Who doesn't know what OSM data is? Almost everyone. Okay. So OpenStreetMap data is basically, it's like Google Maps. You just get all the streets and buildings and everything from something like Google Maps, and you can import those into Houdini. And then you can access all that information. So you know where all the roads are, you know where all the buildings are. And if you're lucky with your information, you also know how high they are, you know what kind of roads you have. And that's really valuable if you want to generate a lot of stuff very quickly. If you want to generate the entire city of LA, for example, within a few minutes, then OSM data is really handy to make a lot of progress in a short time. So a little bit about the stats. This thing right now solves around 800 intersections per second, so that's a lot, especially if you want to make large cities, you want to iterate on them, see if you can make some adjustments or whatever. You want to have high performance. And then we're working with like a lot of UV sets, and we are mainly working in 3D. So if you're doing roads in Houdini, probably you've been trying out something with the PolyXpand 2D, and in the name you have 2D. It's that work with 2D, but when you are working with a city, sometimes you have tunnels, you have bridges, so you want it to be 3D. And that's also what the focus for this thing was about a little bit. So we want to be able to have those tunnels, those bridges, roads going over each other without interfering. So yeah. Now this is then what you see in Google Maps. It's a basic street. And on the next frame we can see this is what we want. We want a nice geometry, textures, for example, UVs, quite a bit more complicated. But we basically have only 4 lines coming together at one point. This is what you get from the OpenStreetMap data. 4 lines representing your roads, then 1 point representing the intersection point. And yeah, this is what we want. We want to have those outer lines of the geometry. Those are the hardest to create because we have not that much data to create these. We need to know the width of the road. We need to know quite a lot of things to generate this. So the outer parts, we don't really care about this too much. This is just a sweep. Those are the red lines. Really easy to get rid of those. Well, you just sweep them or something else. It's a straight line. Don't worry about them too much. But then the green part, this is where it gets interesting because well, this is a simple intersection, but imagine you have 2, like from one side you have, for example, 3 roads come together or multiple lanes or different widths. Intersection gets complicated really, really fast. Whenever you think about a roundabout or something else, like the intersections get really easily complicated. But the green line showed what we want. So we start with 4 lines. This is what we have from our OSM data. Now from here we can kind of calculate the width because the OSM data knows how many lanes. Usually it knows how many lanes each road has. So if you have 2 lanes, you can then calculate by basically the standard width. Like in the Netherlands where I'm from, the standard width of a road is basically 3 meters. I'm not 100% sure what it is in the United States, but you also have standard lane sizes. And you can use those to multiply them with your amount of lanes to get the width. Now, then we can kind of estimate the length of this intersection. That depends on in which area it is, what kind of roads we're dealing with. Is it a highway? Is it just urban area? But when we have this, we can finally construct something in Houdini. We can construct those sign points. So these are basically the outer edge points of our intersection. And that's nice. So this is what we have in Houdini right now. We have 4 lines coming together. And we have some points we know, okay, this is important for the geometry for our intersection. Now, we want to connect those regarding the yellow lines. I will go into this a little bit more when we go into Houdini. But basically we are using the direction from the line to construct these corners. Now, like Ivo already said, like a reference is really important, especially with intersections. Like there are so many different intersections, it's crazy. So let's just have a look at some of the detail we want to be creating. So we see some zebra crossings, we see some gutters, manhole covers, we have the middle lines of the road, and we have, of course, the asphalt itself. Cracks could be appearing at certain parts, depending where you are. It's the countryside road. Like it matters a lot for intersections. Now we're going to go over these per thing. So the asphalt itself, like probably you want to be using world space for this as UVs, because then you have no distortion at all, and that's what we like. But for the zebra crossings, these, like, you think they are really connected to the intersection, but after I looked at them a little bit more, usually they are going from one side of the road to the other side of the road in a straight line. And even if the intersection is a little bit skewed, they don't really follow the intersection that much. So, and it is a straight line, so it doesn't need any deforming regarding curvature of an intersection. So it's probably the best to use decals for these. The same goes for the manhole covers. Well, these almost have no orientation. You can rotate them however you like. They only need to be pointing upwards. So we'll just go for decals with these. But then, like the gutters and all the detail that could be cropping up at the side of your intersection, that's the tricky one, because you don't want any distortion with this, but you rather use styleable textures or such stuff, so you can really generate a lot of intersections without all the manual input from your artist. So we also have the inverse of this. That's basically the middle of the road, so that's not used that much, because in the middle of an intersection there's usually not that much going on, but we do have some middle lines of the like the road marks. And so this is how the first UV set of the system looks. It's basically going from 0 to 1, 0 at the outer edge and 1 into the middle. And this is, you can use this for some masking. You probably don't use it that much. Then the next one is a little bit more interesting. This is mainly usable for the middle parts, because you kind of have a constant width from the middle to the outer parts. So you could get some, depending what kind of track you're making. If you're making some kind of fantasy track, a very sci-fi track, then you could use this for some metal plating, which is in the middle of your track. So, or even masking, that's very determined. It has to be something in the middle of your track. But that's where this first UV set, then the second UV set for used. This one is the most interesting. This one starts at the outer side of your intersection and then goes inwards. And this one is really nice to use for like the gutters or certain wetness maps, because it's like a little bit lower and the water leaps up from there, or some cracks that start to appearing more on the sides of the intersection. So that's what we want to use this one for. Now, we have tackled most of all the details that we are going to tackle. But when dealing with OpenStreetMap data, like the thing you're gonna do the most is cleaning up your input, because you have such a limited input. Although it contains a lot of information, there's still a lot of stuff you need to do to make it fit to your specific needs. So if you look here at, this is from Google Maps, like this is what you see on Google Maps. This is also what you're gonna get from OpenStreetMap data. So in the middle you see one line, then it goes into 2 streets. But now if you look at the real image, like it's very similar what you're seeing over here, and you need to figure out, like all the information is inside of the OpenStreetMap data, because in the first road you have the amount of lanes, so you know what the width is, and the second one you also know that it's split up, so the lanes are also less, so probably 3 or 4. So all the information is there, but it's still going to take you quite a while to clean all of this up, making sure that you can process it correctly, and that's what a lot of time is going to be put in. So now I'm going to dive into Houdini first and then in Unreal to show you guys how the system works currently. Okay, so this is the one where it's currently at. Let's dive in. So we're just using right now a grid. I'm using a mountain node to have some height information, scatter it, and connect adjacent pieces. So I have my basic road setup. You could imagine this is your OSM data. And I'm transforming it for some reasons, and then adding some other roads. All right, now then it goes into the road tool. Now there are a few different sections in here. Like the beginning, the first part is mainly about cleaning this stuff up. So this first node this is mainly about cleaning. This does it also mainly prepares it for the intersection solver. So imagine this is my wireframe, and first what I need to know, that happens over here, I need to know where are all my intersections, because I only want to run all my code over these intersections. Those are the hard things, I want to tackle those. Now if I know where those are, then I'm going to select basically each intersection, and I will be checking, okay, which points is it connecting to, and it will be shooting a primitive to those points. But if that point is also an intersection, it will stop looking. But if it's not an intersection, it will keep on looking for the next primitive, and connects it all into one nice long road. So for example, let's see over here, if this is my initial intersection, it will look first over to this point and see, oh, this is also an intersection. I will only create this primitive, which is linked to this intersection. And it will do the same for this point. But then it sees, oh, this is not an intersection. We'll go to the next point, and it will connect these two as one primitive to my initial intersection. And in the end, that means that I have 3 primitives connected to my intersection point, and they all have the same direction. And that's also really helpful, because that's just easier in the rest of the code. I don't have to worry about the primitives going into the wrong way, or like all the point orders are correct. All the vertex orders are in the nice sorted manner. Now, when that's cleaned up, I'm resampling it a bit, so now I don't need to worry about anything going wrong with a resample. Usually when you have such a wireframe and you place a resample, you get all this weird curves, interconnected primitives. It gets really weird, but that's the thing that's right now solved. So I know, okay, my input is ready to be used, and it then goes into the intersection solver. Sorry for that. I'm creating 3 different things, like a middle line, outer lines, and the geometry of the intersection itself. And that's mainly for a road tool I will showing a little bit later, because those 3 are very easy to. With the outer lines, you can place certain barriers for your road, and then with the geometry of the road is used for, of course, the road pavings, just for the road itself. And the middle of the road, you could use it for something else, placing other certain parts, whatever you are intending to use it for. Now, for the rest, this is not that important, so let's go into the intersection solver and let's go over the basics and how it works. So we have one intersection over here. It's doing this all in one for loop, so there are 2 for loops in total. One for loop is going to select only one intersection, and then the other for loop is going to select like one part of the intersection. And we are at the first for loop, so we're going to select one intersection at the moment. And what we do here is we are collecting a length and a width value from all the data that we had gathered. And those we use then to cut it off. So these parts are not used for the intersection. So this is basically the red part you saw earlier. So for these parts we don't care about in the intersection solver. We can just use a sweep for these. And we have the other stuff like that goes into the intersection solver. And that's what you can see over here. This is the middle part. This is what we care about the most. Now, I have the middle point also over here, and I'm using the middle point to sort the 3 outer points of the intersection, because I have now these 3 outer points are connected are as far as the length value, and I have the middle point for the middle point of the intersection. And I'm going to sort them clockwise, so I'm certain, okay, I'm always selecting like the first segment that's next to the other segment, and then I'm doing the same thing for the next segment, selecting the second segment and selecting the third segment, so you don't have weird stuff going on. Okay, so over here you can see I'm selecting my first point and I'm selecting my second point. Now with those, I'm going to create the inner segment, so the inner line of the intersection. And I will be creating the outer line of my intersection. So if I would view them both, right now it looks like this. The sample size is a bit low, but it doesn't matter. And if I would combine those together, so with all of them together, you get something like this. If there's interest in it later on, I will go more into how I exactly create these curves. For now, we're going to go through to the road tool. So the road tool that we made, this is the exact same road tool I made in a tutorial, which is online. And in here, there's also an intersection solver, but it's also focusing on how do you use all this information from the intersection solver. So how do you use all these points with the right orientation to place other stuff like the pillars and so on. So if we dive in here, this is quite a large system, but don't worry about it too much. This only tackles one intersection. So this is basically in the intersection solver. So we have over here the left part and the right part. Right now we're looking at a straight road, so it doesn't show those. But in the end, we combine all the information towards one road. Now let's dive into Unreal. So we can have a look at this. So this is all, it's still like partially in a work in progress. I'm mainly focusing right now on tackling the OpenStreetMap data, because that brings just a lot of problems depending on where you are, what kind of intersections are you tackling. Like, are you trying to do an entire city, so American cities, a city from Europe? They're all like so different. So, all right. So this is how the road tool looks right now in Unreal. So this is an old one. So the way this intersection is generated is not using my new technique. So it's a little bit weird. This presentation doesn't matter that much. So just like Ivo already mentioned, it is quite similar how he was using his pipes. It's really easy to just select a point of this intersection and move it around, and it updates automatically. So just imagine you're making a racing game, and well, you need to, especially when you're making racing games, you need to iterate a lot, and it's really important to make fast decisions. You're testing it out. Oh, this curve doesn't work completely, adapting it a little bit, and you want everything to look as close as possible to the end result as possible, because But environment does matter regarding gameplay. If there's a certain feel to the road, it's gonna impact how the player is gonna take that turn. It's very easy to work with this thing. So if I would drag this thing in here, I'm dragging in another one. In the beginning, it doesn't work because it doesn't have any curves yet there. So how Houdini works, we have 4 inputs right now. You could give it as many inputs as you want, basically. And let's set it to a curve input. So now we have one line, which is our one road. And you could make this like a different style, doesn't really matter like what you want. This road also has a pillar system in it. So when it gets high above the ground, it will play support for itself. Which is also another task you don't want to hand out to your modelers too much, because it's just time you don't want to waste. Alright, so let's place another few. Like, important to note right now is like the Houdini assets don't talk together right now, because they are, at the moment, they are completely independent. So if I would, for example, place this point next to the other asset, like it will not connect in any way. So because they are different assets at the moment. You can combine them, of course, if you combine the initial curves or do something else fancy. That's also good for one thing, that you can play with them apart from each other, because it does take time to load, of course, and you don't want to load all the roads every time you are playing with them or you're iterating on them. So you want to keep those as separate as possible. Yeah, one more thing I wanted to show is in Houdini, and that's basically how the OSM data works. So if we would, yeah, we have Wi-Fi here. So if we go to OpenStreetMap data, OpenStreetMaps. So it's really easy to get OpenStreetMap data. Let's see, export. There we are. So you look around the globe. You see, okay, what city, what place do I want to make? Then well, we press export. I already have something selected, and you press export. You basically download it immediately, and you have your fancy map. Now, thanks to our wonderful game dev team, we have a very cool OpenStreetMap importer. So we place our importer. We're gonna select our downloaded file, and this is what we get. So it's a bunch of lines and primitives, and each line basically holds a lot of information. And if we would go into our geometry spreadsheet to show this, it's saved in the primitives, and well, you have all this awesome information. Is it a highway? Is it a house? What units are used? How many lanes do you have? What's the maximum speed limit? Like especially in the United States, this information is abundant, and you have so much information you could use for generating your cities, for generating your roads. So that's really cool. It's harder to do this in other cities, in other places in the world, because there's just not that much information available. So that would be mainly you, in some way, calculating it, yeah, in a certain way, or even just placing boxes in your environment. Okay, this is urban area, or this is countryside. It depends on what your project is. It's all very dependent on what you want to achieve. So now we have this information, then we can filter it. So let's do it, because I only want roads right now. I don't want to create any roads where my buildings are. So let's check out all the buildings, and let's check on the roads. All right, okay. Now, and let's just throw this in here. Oh, only there. All right, and let's load it. As you can see, we have intersections and geometry loaded already. It's pretty fast. This is one of the examples of what happens when you have a certain weird thing happening in your OSM data. Because like right now, I'm also not gathering the width of the OSM data for the purpose of the presentation, to keep it a little bit simple. Over here, you can see, if I would check this on, that this, like the width of these two are different. So this one would basically be the combined amount of lanes of the other two roads. So then the width would have been nice, and it wouldn't have this weird overlap. But yeah, you will get some of these problems. You will need to have some. So it's not that hard, but there are like quite some manual saves or adjustments you need to make for every type of intersection. So yeah, depending on what you want to achieve, it's not that hard, but it's just something you need to remind. Okay, and then we have another cool thing. So I'm just gonna show how this works. So these are the intersections right now. And this is my basic control. So the length and the width is the same for every crossroad right now. It's not really recommended, but it's just so what happens when we change it. So if I change the length, you can see it's getting smaller, and yeah, it works pretty fast. And the same with the width. But you could even make this a tool for your artist that the artist can place its own intersection and then just mess around with these parameters to get the intersection you want. And we also have one for the sharpness of the corners. So for example, if you were in a savanna or something, if these sandy crossroads, then you want it to be, you don't want the corners to be too sharp because they will take the long road, for example. Yeah, that's what I've been wanting to show you guys. Right now we're going to go to some questions. We can dive into some more notes if you guys are very interested. Yeah.
Yep, that was it basically, I guess. Yeah, so thanks for having us. Yeah, so first of all, of course, thanks for having us. It's cool that we got to meet like all of you and that we'll have talks later on. And it's cool that you guys listen to us ramble on, especially because there's a lot of people who don't know about OSM data yet, or there's actually some people that have never used Houdini before. So if you have any questions, feel free to ask.
Yeah.
2 quick questions.
Yeah.
For both of the setups, the pipes and the roads, do you generate the collision geometry for the game, or do you just like give it to Unreal and it generates the collision?
Well, in my example, I generate the collision geometry on its own. So I'm just quickly going to go in to the file to show, which of course I closed down for obvious reasons. But basically, I want it to be as optimized as possible. So what I did is in my generator, I actually have a group that's get generated. So even if I were to turn on all the settings, so say that I don't want the work mode and I want all the geometry going on and I want like the difficult curve and whatnot, then this will still only generate this easy geometry. And you can basically build on this. So if there's an example where your stuff gets really big, so this pipe generator, this is like a newer version, but in one of the older versions, it's actually used in the creation of a game. And there they were making pipes that were like the size of like people. They were like 10 feet in diameter, so they were like really big. And then if you have something like the flanges on there, they're like, you know, like a full feet wide, and your character can't walk through them. So then I actually had to add those into the collision as well. But if you're talking about like really small objects, you know, like some simple pipes somewhere out there, you probably just want the actual pipe as the collision geometry. So even like this, it gives the opportunity for you to choose, okay, what's more optimized, rather than have Unreal work over it.
Also, a cool thing for this is that you can very easily change this collision geometry by just tubes and spheres, for example, to make it really, really optimized. So yeah, definitely a plus to generate collision inside of Houdini.
How did you do it on your stuff? You want to show?
It's not in this one, but I'm basically using tubes and boxes and simple geometry which does the job.
Gotcha.
What I recommend doing is using the complex decomposition node in Houdini 17. It basically generates complex halls, which are really efficient for the bullet physics solver.
Cool.
Exactly.
Second question real quick. You said there's 2 sets of UVs for the surfacing. Like one goes from the inside or the middle of the road to the edge of the road, and one goes from the edge of the road to the middle of the road.
Yeah.
And you had 2 just so that one has distortion like over here where you don't want it, one has distortion over there where you don't want it. Is that the point?
So yeah, basically like every UV set, which is not world split, has distortion. But I can go in there. Let's just open it. So yeah, those are designed to tackle certain types of detail with a certain UV set. So let's just open this. And let's go down. I think it's in here. Yeah, great. So let's turn on my textures. And let's set a quick shade over here. So this looks right now weird, it'll depending on which game engineering subdivide a little bit more. Okay, so this is the first one. So over here it starts at 0, and here it's 1. So it basically goes from in the U direction 0, 1, and then in the V direction also 0, 1. So that's basically our 0 to 1 square. You could multiply this with like its distance or something to get away with other certain type of distortions. But for a tiling texture, I found this very inefficient. Then if we would like this one, yes, and I will go in, and we're gonna grab the second one. So right now it's very small. So this one is the one that starts at the bottom. So right now it's kind of skewed because I messed a little bit with the length and the width of the attributes. But because this starts at the side, like I'm not 100% sure. Like, what would you like me to explain about it?
Just the rationale for having the two sets and like what each one is.
Yeah. Okay.
So like with the last one, actually, I couldn't tell that there's much distortion on either side.
Yeah, so the last one is not really that usable for a lot of stuff. Like for masking, mainly it would be used for like if you have at the middle road or like where skid marks are, or like mainly for masking. So you don't need that much. You don't care that much about the distortion. And this one is mainly almost not distorted like at this side of the road.
Okay.
So that means that your gutters and that kind of like cracks that are at the side of the road, you can mainly well place them with this UV set. And then there is the third one, which is this one. This one is it also depends. Like for some very certain intersections, you could use this for some kind of zebra crossing, but I wouldn't recommend that. But it's mainly for having the middle road, because the width is constant in the middle, so there you don't have that much distortion, so you could use it for some kind of middle line. And it's also, those usually exist mainly at the beginning, and that's also where the distortion is the lowest, because you usually don't have that many of the middle lines at the center of an intersection. So that's how I would use them mainly.
Cool.
Have you guys ever encountered like roundabouts that are hard to deal with, or does it handle it pretty well?
So a roundabout, if I go into the OSM data, I'm not sure, like United States doesn't have that many roundabouts, right?
Or Michigan, there's one.
You got one? What?
No, I don't have one.
Michigan and 14th.
Okay, let's type that in. Let's see if we can find that.
Like, sorry, I have no idea how you spell it. I don't know.
It's fine. What? I have to type. I don't know how to type.
Yeah. You talking about jump handles?
And then what?
Try Michigan and 12.
I don't know where that is. Michigan? Is it Michigan Street or?
There's 1 and 2.
What?
It's an intersection.
What? What?
Put and.
Is there, what? Yeah, I don't know if it's gonna find any of this, but.
Oh, this is not
Yeah.
really a roundabout.
Well,
Yeah.
Is it? Is it? We can try.
That's
There's a mini one. Yeah, there's one right there.
You want to try that one? Let's see what it does.
You can't really call this a roundabout.
No,
It's
that's
like
not right.
that's not a
Yeah, the
roundabout.
one on the cul-de-sac. Oh, yeah.
There's no roundabouts.
The intersection of Michigan Avenue and 12th Street.
Okay, so Michigan Avenue. Just type out.
Could you? Yeah, they found it.
Michigan Avenue, and then
12.
where's 12?
Yeah,
That's
supposed
Fifth
to be
Avenue.
there. So, but do we have paint? I can paint stuff.
Sorry.
It's fine. We have paint. All right, this is gonna be wonderful.
Microsoft 8?
Yeah, wow.
There's a whiteboard behind.
There's a little whiteboard. Okay, I'm just gonna draw it.
And this quality or
So, usually how it looks when you have a roundabout from OpenStreetMap data is you have your, that's fine. You have your incoming roads. I'm going to draw 4. And actually they are existing out of a lot of smaller intersections. And you should think that like the intersection, like the length should be around here, and then around here, and around here. So that would be meaning we would kind of connect it like this together, which knits a nice circle. Well, it should be a nice circle. And it does the same thing for the outer parts, and then connects it like this. So roundabouts are actually easier than you might think, because they really follow this system quite nicely. You have enough room usually, depending on which country you're in for your roundabouts. In the Netherlands we have really small roundabouts, so they're a little bit harder, because you don't have that much room to play in. But it's mainly existing out of smaller intersections, which yeah, it's quite doable. You need to do a few adjustments, especially because you want this curve to be as round as possible. But that's certainly doable, because you can, it's not that hard to recognize where the roundabout is. And if there's a roundabout, you can basically detect this edge, and then with some little bit of coding, make it nice and round. So that's basically more how you would, how I would tackle the roundabouts. So it's easier to think because it's just a lot of small intersections very close together.
I have a more applied question. So I do deal with like Alzheimer's disease and dementia, and if you could, how long would it take? Let's just say like spatial disorientation is a big thing. Like people walking out of their homes and not knowing where they are. So potentially some training, like how in terms of creating a road around the house. So how long would it take to make like a 10 by 10 area of like the roads of like around your house in terms of like a typical street?
Well, it depends. What do you mean with like the 10 by 10 streets?
Like yeah,
Well,
10 streets this way, 10 streets that way.
Well, as you saw before, it's just basically selecting the specific area, which could be a 10 by 10 in OSM, and getting that in there.
Yeah, it depends mainly on how specific is the neighborhood. If you already have quite some prefabs you can use, for example, to make the buildings. The buildings are the largest problem over here. Like the roads are the easiest part of this the story. So the roads will be within a second or something. It's easily to do that. But mainly the buildings, making sure the buildings look familiar and having nice prefabs for those, because that's the hardest part in this story. So that will be taking, depending on how you do it. If you have prefabs for everything, it's easily done, almost real time. But if you really need to generate those from pictures or something, then it's going to take way longer. So yeah.
Following on that question, have you made like a street map or something, and then used the projection of the Google Maps, like the actual keyhole satellite picture? You ever like put that down onto the geometry that you made?
Yeah, that was the beginning to trying to understand how the curves work. So basically comparing them together, I had my own first initial interaction over, and in some cases it was all right, mainly with when they come together perpendicular to each other, 90-degree angles. But for all the other parts, I just laid them over each other and looked, okay, just basically drawing over each other. So how does it look? Yeah.
Was it ever an intention to have that be part of the asset that you've created, the setup that you've created?
No, not really. Like this thing is really a mainframe for a lot of intersection solver. So the goal of this intersection solver is that you can use it for, it's your starting point when you're making a road tool for a game or for something else.
Not just to recreate what's already there, but so that you can create new things.
Yeah.
I got you.
With OSM data, does it also include meetups? That way you can key in the like overpasses and underpasses?
You do have, depending on where you are, you have a lot of information. You have, sometimes it tells you if it's a bridge, and then you are certain that it's going over other things. But you do have a layer attribute, and that is basically determining on which layer of the roads are they. So you can see inside of Google Maps, you can see when they overlap. And that's because they have their own layer attribute. And that's also what you have inside of which you can get in Houdini then, and that's really useful for getting an estimated height. It's not perfect, but it does get you pretty close to some nice looking results. So yeah, you can do some cool stuff with that. And then the other parts of the terrain you can get with the map box. You can get quite some terrain values already from there to get the right height according and overlay them with your terrain basically. So yeah, you can get quite some information.
Okay, I guess that was it. So thanks again, and let's meet you outside for some drinks.
Yeah.
Thanks.